students. In this video, we are going to see how the sign convention for reflection by spherical mirrors. What about the sign convention of reflection done by spherical mirrors? In this topic, light reflection and refraction of class 10. Hope you all remember what is the Cartesian plane. Cartesian plane is the x and y axis drawn perpendicular to each other and they meet at the origin. The plane which we draw in a graph sheet. So this is a Cartesian plane in which O is taken as the origin and x dash are the horizontal line and y and y dash is the line perpendicular to x axis. It is drawn vertical and both the lines meet at a point O. We call it as a Cartesian plane. And in a Cartesian plane, O is the origin and the values left side of O is taken as negative and the right side is taken as positive. So these are negative values and these are taken as positive values. Similarly, above the x-axis, y values are taken as positive and below it is taken as considered as negative values. In the same way, you can compare this figure with a Cartesian plane. Hence, it is said that mirror formula and magnification, and it is done according to new Cartesian sign convention for spherical mirrors. So you have seen in the previous videos the formation of the images in convex and concave mirrors, the spherical mirrors. Here this is a spherical mirror and what type of mirror it is? A concave mirror, because on the curved part here the object is kept in front of it. So it is a concave mirror. And you have seen what type of images are formed. Already you know what type of images, different types of images are formed when the object is placed at F, to F, beyond to F, at infinite. Most of the time when the object is placed at different position, if it is a concave mirror, you used to get a real image, inverted image, and the size of the image depends upon the distance. When the object is brought nearer to the mirror or taken far from the mirror, the size of the object magnification, or you will get a diminished image. So, comparing it, we are going to study the mirror formula and its magnification. Let us consider here a concave mirror. You can see a line drawn horizontally and it passes through the hole of the mirror, the center of the curved surface. So this line is known as principal axis. Now we are going to compare this figure with the Cartesian plane. So in a Cartesian plane, the principal axis is considered as the x-axis and the whole of the mirror is considered as the origin. So since here the left side of the origin is taken as negative. Here we have P as the origin. The left side is taken as negative and the right side is taken as positive. Hence, when we are going to keep the object to the left side, always we used to keep the object on the left side of the mirror. Hence, its distance is taken as negative. Here we are going to take the object distance as u. Object distance is always u is the object distance. The distance between, what is this? It is the distance between the pole of the mirror and the object. This total distance is taken as u. And since the object is always kept on the left side, it is taken as minus u. Next, here AB is the object and minus u is the object distance. We are going to get, if it is a concave mirror, an inverted image of this object at some point on the principal axis. Here we have taken B dash, A dash. A dash, B dash is the image of this object and the distance between the pole and the image, it is taken as V. V is considered as the image distance. It is the distance between the pole and the image. And since in a concave mirror, we get the image on the left side itself. Here we get minus V. If the image is on the right side of the mirror, then it is taken as plus V, because on the right side it is positive. And here this height is taken as object height. AB is the height of the object and it is represented by H. H is what? Height of the object. And what about H dash? It is the height of the image. A dash, B dash. That is the height of the image. And here we wrote this as positive, negative, and this one as positive. The reason is this is the x-axis and this is the y-axis. So here the line above the x-axis is taken as positive, hence AB is considered the height as plus h. Whereas A dash, B dash is below the x-axis, which is considered as negative. Hence, height of the object is minus h dash. And also, this negative sign in magnification represents that the object is real. If it is a virtual object, like how we are getting in a plane mirror or a convex mirror, then the magnification value of our h dash will be positive, because we will get an erect image. When it is erect, it is a positive value. So it is a virtual image or erect images and it has a positive value. Okay. So h dash is the height of the image, h is the height of the object. And what about f? F is the focal length of the lens. You know what is focal length? That is the distance between the focus and the pole. Focus means the point where you get the image. So the distance, this is the point where you get the image, this is the focus. And the distance between the pole and the principal focus is called, this length is called as what? It is the focal length of the lens and it is different for different mirrors based on their center of curvature. Okay. Now, what about the mirror formula? The object distance, mirror image distance and the focal length. These three together forms the mirror formula, that is 1 by V plus 1 by U is equal to 1 by F. That is the reciprocal of the image distance. Suppose if the image distance is 5 centimeter, what will be its reciprocal? If V is 5, you have to write 1 by 5. Here 1 by 5. If U is 10, you have to write 1 by 10. That is equal to 1 by F. So this formula is used to find out the focal length of the mirror. If you don't know the focal length of the mirror, then you can use an object. You can place it in front of the mirror, find where you get the image, measure the distance of the image from the pole, and also you know at what distance you have kept the object from the pole. So using it, you can find out what is the focal length of the mirror. So the formula used is 1 by V plus 1 by U is equal to 1 by F. And after getting this, if you take the reciprocal of it, again suppose if you get 1 by F as 5 centimeter or 10, whatever it is, then you can, after calculation, if you get it as 1 by F is equal to 0.25 centimeter, then what is F is equal to 1 by 0.25. You have to take the reciprocal of it. Next comes, so this is how we can find out the focal length of the mirror. Next, what about magnification? Magnification is the ratio between the height of the object image divided by the height of the object. Height of the image by the height of the object, and it is also related to the distance of the image and the object. It can be written as h dash by h is equal to minus of V by U, because always U will be having a negative sign. Hence m is equal to h dash by h, or it is equal to minus V by U. So that we can suppose after calculation, if you get the value as negative, it represents that the object, the image is a real image, and if the value is a positive value, it means that the image is a virtual image. So this one shows how much what is the magnification, how big or how small the image has been got compared to that of the object. So this is how we can find out the formula to calculate the focal length of the given mirror using new Cartesian sign convention. This is named as Cartesian sign convention because we are comparing it with the Cartesian plane. Here, example number 10.1 in the lesson, light reflection and refraction, is given as a convex mirror used for rear view on an automobile, has a radius of curvature of 3 meters. If a bus is located at 5 meters from this mirror, find the position, nature and size of the image. Means here the radius of curvature R of the convex mirror is given as 3 meters, and the object, here a bus is considered as the object. It is located at a distance of 5 meters away from the mirror. So what is the bus here? It is the object. The distance of the object from the mirror is given as 5 meter. We are going to take it as u. So r is 3 meter and u is 5 meter. You have to find the position, means how far or at what position the image is present. That is the distance of the image from the mirror, and also nature and size. We get it by finding out the ratio, magnification. Whether from magnification we can make out whether the image is smaller than or bigger than the object. Here h dash represents the height of the image. So if we know h dash, we can say what is the nature of the image formed. So let us consider the data as r is equal to 3 meter, u is equal to 5 meter. To find the nature and the position, nature and the size, we should know what is v is equal to, that is the image distance and the height of the object image. As we know already, the relationship between the focal length and the radius of curvature is, focal length is half of radius of curvature. Hence we are taking f is equal to r by 2, that is equal to 3 divided by 2, because r is 3. 3 by 2 gives you 1.5 meter. Next, to find what is v, we have to use the mirror formula. That is 1 by v plus 1 by u is equal to 1 by f. 1 by v is equal to 1 by f minus, this will become minus when it goes to the other side of the equation. So 1 by f minus of 1 by u, and 1 by f we know it is 1.5 meter. So we are writing it as 1 divided by 1.5 minus 1 by, why we are writing minus 5? Here the image distance, as I said earlier, the image of the, not image, object distance. Object is kept on the left side of the mirror, therefore whole of the mirror. Hence we are taking the object distance, always we have to take u as minus of the value. Hence we are writing here minus 5. But what is minus of minus? It becomes plus. So 1 by 1.5 plus 1 by 5 is equal to 1 by v. Now if you take LCM, 1.5 into 5 gives you 7.5. Then just cross multiply. 5 ones are 5 plus 1.5 into 1 gives you 5 plus 1.5 divided by 7.5. That is 1 by v is equal to 5 plus 1.5 gives you 6.5 divided by 7.5. Now what is the reciprocal of this? 1 by v is equal to v by 1. Otherwise v, it is equal to, you have to take the reciprocal of the other side also. 7.5 divided by 6.5. So when you divide 7.5 by 6.5, you will get 1.15. You know how to do that. Multiply both numerator and denominator by 10. So you get 75 by 65. When you divide 75 by 65, you know the division. So when you divide it, it is 1.15 meter. Hence, what is v? It is the image distance. Image distance is 1.15. See, what is the object distance? It is minus 5, whereas the image distance is plus 5. Plus 5 means it is on the right side. That is the other side of the mirror. So if it is going to be on the other side, it should be a virtual image. Hence, we have got a virtual image because V is plus. We got what type of image? It is a virtual image. When it is a virtual image, it will be an erect image. Hence, the image is a virtual and erect image. Next, we have to find the size of the image. For that, we need magnification. What is magnification? M is equal to h dash by h. That is equal to minus of v by u. So h dash, we don't know both the values. So h dash by h is equal to minus of, what is v? It is 1.15 divided by u is minus 5. Here we got u as minus 5. Hence, minus of minus becomes plus. 1.15 divided by 5 gives you 0.23. Now you see here, if you get this value equal to 1, then the size of the image is same as the size of the object, because object size, image size divided by object height. If it is equal to 1, both the heights are equal. And if it is more than 1, then the image height is more than the object height, but it is less than 1. Hence, from this we can say that the size of the image is 0.23 times smaller than the size of the object. Hence, we have got the image virtual, direct and smaller. And as you all know, in a convex mirror, whatever is the position of the object, the image, what type of image we get? We get a diminished, erect and a virtual image. So since it is a convex, see here, always a rear view mirror is a convex mirror, isn't it? Since it is a convex mirror, we got virtual, erect and small, diminished image. You all hope you understood this. Let us see the next example sum. We are going to solve two sums. The first one is the radius of curvature of a convex mirror is given. You have to find the focal length of the mirror. And you all know the relation between the focal length and the radius of curvature of a mirror is f is equal to r by 2. Hence, since it is given r is equal to 32 centimeter, f will be equal to r by 2, that is 32 by 2 gives you 16 centimeter. This is a simple sum. It is given asked in your textbook. The next one, in the exercise part, question number 12, it is given that an object is placed at a distance of 10 cm from a convex mirror and the focal length of the mirror is 15 cm. Find the position, nature and the image. Position is nothing but what is the image distance and whether it is a small, virtual, erect, what type of nature it has. For that, we have to find out what is the value of V and what is the value height of the image formed. So, here according to the question, the object distance U is equal to 10 cm and we are going to take it as minus 10 cm because the object is placed on the left side of the mirror and the focal length of the mirror is 15 cm. Let us calculate what is the image distance V and height of the image h dash. For that, we have to write the mirror formula. According to the mirror formula, 1 by V plus 1 by U is equal to 1 by F. 1 by V is equal to 1 by F minus 1 by U. And that is equal to 1 by F is 15. So 1 by 15 minus 1 by U is minus 10. So minus of minus becomes plus. So 1 by 15 plus 1 by 10. You have to take the LCM for 15 and 10. That gives you 150. 15 into 10 is 150. And then 1 by D is equal to cross multiply. 10 ones are 10 plus 15 ones are 15 divided by 150 or 10 plus 15 gives you 25 by 150. So 25 6 are 150. Hence we can cancel and write 1 by v is equal to 1 by 6. Otherwise, when you take the reciprocal, v will be equal to 6 centimeter. Hence, we got the image distance v is equal to 6 centimeter. Now, let us find the magnification. M is equal to h dash by h. That is equal to minus of v by u. This is the relation. Hence, h dash by h is equal to minus of v value is 6 centimeter divided by u value is minus 10 centimeter. Hence, if you divide 6 by 10, you will get 0.6 and minus of minus becomes plus. Now, here the plus sign indicates it is a virtual image and a direct image, as well as the ratio is less than 1. Is the image is a diminished image. Hence, a virtual mirror and diminished image is formed, and it is behind the mirror, because in a convex mirror we used to get a virtual image. Where will you get the virtual image? Behind the mirror. So this is the nature of the image formed.